So hello students, welcome once again to our YouTube channel. So that was the question for today from theory of equation. See, just looking at the question, since we have already discussed that format, though the question is different, of course the question is different, but looking at the equation itself, I believe that now you have the idea how to start with. So what's so special in this equation? The speciality is the highest degree term and the constant term has exactly same coefficient. You remember this? We have already discussed such type of equation beforehand. Okay, and the second highest degree term coefficient and the second lowest degree term linear term coefficient should be same magnitude wise. Here they are same in all terms, magnitude wise, and same like sign wise, and then you have a middle term. So how we start? We start by dividing the entire equation by the middle term degree term, like x square here. So dividing it by x square, what do we get? And collecting the similar looking terms. So x square plus 1 by x square at one place, and say p minus 1. So p minus 1 common x plus 1 by x at one place, and then plus 1 equal to 0. Now here again we know how to approach. We know that we'll be expressing this as a perfect square in the form of x plus 1 by x. So it is x plus 1 by x whole square minus 2 plus p minus 1 into x plus 1 by x plus 1 equal to 0. Okay, so now x plus 1 by x. So let x plus 1 by x is equal to t. X plus 1 by x be t. So this imply you get t square minus 2 plus p minus 1 times t minus 1, I think it's plus 1, I believe, yeah, it's plus 1 equal to 0. So now that you have a simple quadratic in terms of t. Okay, so t square plus p minus 1 times t minus 1 equal to 0. Now let's get its roots. Okay, so see, I haven't discussed the exact statement of the question. So just by looking at the equation, this is how we need to start. So just when I looked at the equation without thinking anything else, I just converted it to quadratic form because I knew I can convert it to quadratic form because of this type of equation. Okay, now let's read the question. Find all possible values of p for which the equation has at least two distinct negative roots. It has two distinct negative roots. Okay, so now if I try to get the roots here, so t is minus times minus b, सीधा चार formula, under root of b square minus 4ac, okay, upon 2a, which is 2. But do we need solution in terms of t? Answers, of course not. Our variable is x, so I will be replacing t by x. So this implies actually we have to solve for x plus 1 by x, and having at least two negative roots means having negative roots means x should be negative. Okay, so x plus 1 by x is minus p plus 1 plus minus under root of p square minus 2p plus 5 by 2. Now see, there's something special about this one also, and what is it? See, it says, we know it, that if x is positive, this implies x plus 1 by x is always greater than equal to 2, and what? And if x is negative, what does that mean, bachcho? That means x plus 1 by x will be less than equal to minus 2, and since we need negative roots, so negative roots you will get only when this is there. Only when x is negative, then only we can have negative root. What does that mean? That means if we are claiming that this equation has any real root, I am talking about just real roots. Okay, so that means this should be either greater than equal to 2 or it should be less than or equal to minus 2. But since we need negative roots, so it has to be less than equal to minus 2. So that's the condition which I am going to apply here. So what does that mean? That simply mean I will be using minus p plus 1 plus under root of p square minus 2p plus 5 is less than equal to minus 4. Now what did I do? I'm claiming here, see, there are two possibilities, this plus that and this minus that. Okay, now I am claiming that if with positive sign, if this number or expression in p gets less than -2 or less than or equal to -2, then with negative sign it will definitely be less than equal to -2. Okay, so if this happens, then of course we will have the answer, and both answers will be negative, the roots will be negative. So let's solve it. Okay, so I will take it that side, so it's p plus 5 is greater than equal to, rather p minus 5, I'm sorry, it's p minus 5 is greater than or equal to under root of p square minus 2p plus 5. Now RHS is always positive. Why? Because it's square root. Square root can neither take nor give in negative value. But so, and since LHS is greater than RHS, so doesn't that mean that p should be greater than equal to 5? I think I'm clear here, bachcho. So before imposing this condition, I'm not going to take a square both the side. Okay, so I'm ensuring that both the sides are positive. Why so? Because LHS is to be greater than some positive number. So LHS, for that sake, LHS has to be positive. Okay, so after imposing it, taking square both the side, we will get p square plus 25 minus 10p is greater than equal to p square minus 2p plus 5. Now what do we get? So it's 8p is less than equal to 20. So we get p is less than equal to 5/2, but that's a contradiction. Here, for this to hold, p should be greater than equal to 5, but what we got after solving it, p is less than equal to 5/2, so that's not possible. So that means now we will have to explore the second possibility, that is with negative sign. So minus p plus 1 minus times under root of p square plus 2p, I think it was minus 2p plus 5 is greater than less than equal to -4, right? So there are two things here which I need to correct. So it's minus and less than equal to -4. Now again, taking it that side, bringing it this side. So minus p plus 5 is less than equal to under root of p square minus 2p plus 5. Now see, this is positive and this is LHS. So LHS is less than a positive number. So that doesn't make any difference. It might be positive, it might be negative. So I don't feel any condition is required here before we square it. Okay. So squaring both the side, p square minus 10p plus 25 is less than equal to p square minus 2p plus 5. That again gets cancelled. 8p is greater than equal to 20. So p is greater than equal to 5/2, and that's the condition C. Now what does that mean? If p is greater than equal to 5/2, that means x plus 1 by x. So if p is greater than equal to 5/2, what does that mean? X plus 1 by x is less than equal to -2. Now see, since that's always true, so whenever you solve it, you will get real x for sure, and both will be negative because this holds only when x is negative. So according to me, the answer is p is greater than equal to 5/2. So if anyone has any other way of doing it, approaching it, okay, let me know please. So you can let me know, of course, with the help of comments on the video itself. Okay, chaliye bachcho, we will be meeting in the next video with next question.